Saxon Algebra 1, lesson 116. We're going to talk about a little bit about square roots, pigs and their pig houses, as you know. And the whole reason we call them pig houses is because it's very easy for the creatures living inside them. They can share a house if they want, or they can split up and go into separate houses. They can build them out of straw, they can build them out of sticks, they can build them out of bricks. Wait, no, these are all just written. But we can go back and forth between these two forms, right? They must have lived together in the beginning because then they set out and they built their individual houses, but then as the wolf came and started blowing them down, then they ran and started sharing together again. So that's why they're called pig houses. It's just one of many reasons why the metaphor holds so beautifully. I have a video of an old, I think it's a Disney, like a super old black and white Disney version of the Three Little Pigs that is on a playlist on my YouTube channel. If you ever want to see the history of that metaphor, look at that. And vice versa, not vice versa, in the same vein as this, if the pigs are living in a condo, I'm not sure. They can do the same thing top and bottom as they can side to side, right? If they're living together as a shared fraction, we can split them up and give them separate houses, still in a fraction, but they can each have their own houses. Or if they're like this and we'd like to put them together, we can do it that way. So we can go back and forth between these forms however we want. Now, there's something important about this form, and I'm going to start the example to explain it to you. We're supposed to simplify this. Okay? All right, so we know, all right, let's split these guys into their separate houses. That's fine. We prefer this to this. This is better. But there's still a little bit of a problem. We don't like this. No radicals in denominators. As mathematicians, squeezing, there. We don't like radicals in our denominators. They make us angry birds. Okay? We don't like them. But here's the good news. There's an easy way to fix them. I'm going to rewrite it down here because I wrote my angry messages over here. Can you see that angry face? I'm really proud of it. I'm rewriting. What we do is we call it rationalizing the denominator. All we have to do to fix this is multiply the denominator by what's already there. You know that if we multiply any thing like that, any pig by itself, we get 2 in the middle, and we know 2 pigs in the house equals 1 pig out of the house. Off they go, jumpy. It's easy to see with numbers too, like if we do square root of 6 times square root of 6, we'll get square root of 36. Oh, we know what that is, that's 6. But we got the original numbers back again. So by doing this, we are guaranteed that we're going to have a plain 3 on the outside, right? 2 pigs in the house equals 1 pig out of the house. But if we do the bottom by square root of 3, we have to do the top as well, right? That has to be equal to 1. This becomes square root of 15. Now, some people say, that's gross. I'd rather have it look like this than this. But you know what? Mathematicians learn to love it. This is the form of the answer that we prefer because there's no radical in the denominator. We have rationalized the denominator. And I'm just going to say denom because I can't fit it all. All right? So that's what this is called. Rationalizing the denominator means turning it from a pig to a nice, reasonable, rational number. Let's do another one. There's 2 more. We're going to do lots of this in the future. Next year. 116.2. This one looks a little crazier. Oh, wait. Let me rewrite it. What's this? We have a binomial lurking in our numerator. No worries. We still want to rationalize the denominator. We do it by multiplying it by itself. We know that that is going to make it into a very happy plain old 2, right? However, we must do this as well. Quickly, binomial, wrap yourself in parentheses. Stay safe. Now, we simply distribute. So our numerator will be 4 times the square root of 2, right? Wolves with wolves, pigs with pigs. We don't mix those together. These two little piggies can hop happily together though. Plus square root of 6. We have to be careful about simplifying, but this one can't be simplified. 6 is simply 3 times 2. There's no pair of pigs to pull out. So this is our final answer. All right, and one more. Looks kind of like the other one. This one we just did. Okay, so we go straight to the denominator. We don't care about the top. That's just going to have to deal with whatever we have to do to fix down here. The top just has to deal with it. So this becomes just plain old 5, right? 2 pigs in the house equals 1 out of the house. But we have to do this quick. Parentheses to the emergency. We're going to multiply. All right. Now, I'm going to do that work down here because I want a little bit more room before I write it in my answer. 2 times the square root of 5 is the first part, right? Wolf and a pig, so they don't mix. Now, look what's happening here, though. I'm not going to multiply them together. I'm going to put them into the same house. 15 times 5. Now, that's helpful to see the pieces because I know that 15 can also be written as 3 times 5. Look what happens. Now we have a pair of pigs that merrily jump out of the house as a single pig out here. And what's left inside? That. So our final answer is 2 times the square root of 5 plus 5, the 5 that jumped out, times the square root of 3. That's how we simplify. My best advice to you on simplifying with these rooty roots is don't multiply everything together because then you just have to pull the pieces all apart. Just leave the pigs separately, break down if you need to, like if some of them are still bigger, break everybody down into its prime factors and then look for matching pairs, all right? To a certain extent, you'll be able to do that in your head, but doing it by writing it out is a really great way to start this process and get yourself in the habit. This is correct. And this is also correct. Did I check the first one? Yes, that's right. Guess what? This is the last time that I'm gonna say, we're not quite done, but we're almost done with our lessons for the year. Next week, I will say, over, study for that final. The final exam is nothing more than one more midterm on the most recent set of lessons. As you can see, we've only learned, 6 lessons. So I will go back halfway, more or less, right, for our review. It'll be just the same, 10 problems, 5 points each. If you are not a local student, but you'd like to take my final, shoot me an email and I will send you PDFs. This time, I'll try to do it on a more timely basis. Somehow that is the piece that has slipped past me. But we're done for this week. Thank you. Goodbye.